Good morning, everyone. In the last class, we have discussed about the discovery of electron, proton, and neutron, different initial atomic models like oil droplet model, Thomson's model of the atom, as well as the Rutherford's model, along with the discovery of the nucleus. And now we will have to start the next model, that is the Bohr's atomic model. We have already discussed that the previous models are not in your syllabus this year. So we are going to discuss about the Bohr's atomic model. So when we are talking about the Bohr's atomic model, then according to Bohr's atomic model, the electrons rotates in the different discrete orbitals. And for that discrete orbital, whatever the basis was there, on what basis they have said that the models, that the orbitals are the discrete, on that topic when we discuss the nature of light, what is the nature of light, and on the basis of the nature of light we discuss the discrete nature of the orbital. So in this class we are going to discuss about the nature of light. When we discuss the nature of light, first of all, we were thinking that the light is wave by the nature, a perfect classical wave. But when you have studied in the lower classes, especially in the class 10th, then teacher said that the wave can't travel in absence of medium. And if waves can't travel in absence of medium, then how the light is traveling from sun to earth? In between sun and earth there is vacuum. There is nothing in between sun and earth. And in absence of that medium, in vacuum or the absence of medium, whatever you want to say, in the absence of medium, how the light is capable to travel from sun to earth? That was the problem. Even some of the scientists have said that the universe is a thin solution of ether. And in thin solution of ether, the light, which is wave by the nature, can travel. But actually, the universe is not a thin solution of ether. That is proved. And so, we can't stick with that classical theory of the wave nature. Now, then what is the light? Another scientist, Mr. Newton, said that the light is particle by the nature. And he explained that light is particle by the nature that can be explained on the basis of some of its property like refraction, reflection, etc. He said as the light have the angle of incident equal to angle of reflection. Similarly, when a ball strikes on any of the surface, if the surface is totally plane, then the angle of incident must be equal to angle of reflection. So that is following the rules. The second one, the refractive index. Refractive index says that with the different concentration of the material, the velocity of light changes, and velocity in first medium by velocity in second medium, that is the ratio of the two velocity of the light in the two different medium, is called the refractive index. Similarly, the particles can also vary their speed in two different mediums. अगर हम सिंपल सी अपनी बात करें, अगर आप कितने भी अच्छे रनर हैं, आपको पानी में खड़ा कर दिया जाए और डेंसर मीडियम, तो आपकी स्पीड क्या हो जाएगी? श्योरली दैट विल बी स्लो विथ रिस्पेक्ट टू योर स्पीड इन नॉर्मल एयर. सो श्योरली द मीडियम चेंजेस द वेलोसिटी. सो ऑन दैट बेसिस यू कैन से that the light is particle by the nature, and the size of the particle is too small that we are not capable to identify the strike of these of the lights. But when you will see some of the other property of the light that cannot be explained by the particle theory, then again we come back to the wave nature. What were the properties? The first one, the interference of light. When two light beams interfere with each other, we are not capable to see in that zone. That is called the fringe formation. That is called the interference of light. एक हम आपको सिंपल से एग्जांपल से एक्सप्लेन करने की कोशिश करते हैं. When you travel with your vehicle, bike, car, whatever it is, and the next vehicle is coming from the next side, आपके सामने से कोई व्हीकल आ रही है, देन व्हाट हैपेंस, जहां पे दोनों लाइट्स एक दूसरे को, लाइट बीम्स एक दूसरे को इंटरफियर करती हैं, वहां पे आपको कुछ दिखाई नहीं पड़ता. एक्चुअली यू फाइंड दैट एवरीथिंग इज ग्लोइंग but nothing is perfectly visible. That specific condition is called the interference of light, and that cannot be explained on the basis of the particle theory of the light, because we know that if the x number of particles added with the y number of particles, then the total number of particles will be x plus y, and if the number of light particles are increasing, then white is not visible. Then it was said that according to wave nature, when oppositely moving waves comes in contact of each other, they cancel the effect of each other. So fringe formation takes place, that means light, dark, light, dark, light, dark. In this way fringe formation takes place, and that fringe formation is responsible for the condition that in the presence of in this heavy amount of light, we are not capable to see that what's going on in front of us. So we can say the light is not particle. So whether this one fact is capable to explain that light is not particle. One more fact, the diffraction of light. You have seen when light passes through a pinhole. आपने भी देखा होगा आपके डोर्स में कभी कभी छोटे छोटे से होल्स होते हैं. When light passes through a pinhole, what happens? If the light is particle, that must follow the first law of motion. That will remain in the straight line. That will move in the straight line. But what happens actually? When the light passes through that pinhole, the scattering of light takes place. How the scattering of light is possible? According to law of inertia, the light must move in the straight line in absence of any of the external factor. So that must have to move in the straight line. But actually the light is scattering. How it's possible? It's possible because the light is wave by the nature. As the waves are moving in the wavy motion, so when they strike the wall, if they are striking here, they will turn in this direction. If they are striking upward, they will move downward or in the similar way. So you can say the light is wave by the nature. Finally, scientists says that light is wave, but not the ordinary wave, but not the classic wave. It is a unique type of wave, and that type of wave is called electromagnetic waves. What are the special property of the electromagnetic waves? They said that the electromagnetic waves the energy of the electromagnetic waves depends upon the frequency and wavelength, not the intensity. That means the energy of wave is proportional to its frequency, and energy of wave is inversely proportional to its wavelength. All the light waves are not identical. They have the different energy values. Some have the lower energy value, some have the higher energy value, dependent on their frequency and wavelength. So the light have the different energy values. The next thing what it have said, that these are the systems, that is the electromagnetic waves, can travel even in absence of medium, because they are showing the property of the particles. See here, if this is the direction of movement of wave, electromagnetic wave, then in presence of this wave, the magnetic field will develop somewhere here, that is the perpendicular to the direction of the movement of wave. अब यहाँ पे wave इधर जा रही है and it is moving upward downward, that is the perpendicular. And where the electric field will develop? Surely perpendicular to both of these, and that perpendicular lays somewhere here. So we are not capable to draw out of the board, because the board is just two-dimensional system. We have to draw in the third dimension. So I am trying to draw it with the dotted line. So this is the first, second and third. These are the three dimensions in which they are moving. and electromagnetic waves are capable to show the dual behavior. Then whether these of the systems are actually showing the particle nature? Surely they are showing the particle nature, and that particle nature can be explained on the basis of the photoelectric effect. So what is the photoelectric effect? When we talk about the photoelectric effect, then generation of electricity with the help of the photons, that is the light, is called the photoelectric effect. You have seen in your daily life the solar panels. What are the solar panels? Solar panels are those of the device which converts the light energy in the form of electricity. Then how that conversion takes place? When you will talk about the nature, actually we can say that this is the solar panel on the activated metal surface. And if it is the activated metal surface, when light strikes on it, the emission of electrons takes place, and that is suggesting the particle nature of light. Now you can say that how it is showing the particle nature of light. Light is striking, electron is removed from the system, then how it can explain the particle nature of light? Surely it can explain the particle nature of light. When you have studied the third law of motion, then your teacher said that every action have equal and opposite reaction. And the formula was m1 v1 equal to m2 v2, mass of first one into velocity of first one equal to mass of second one into velocity of second one. If you will strike with the greater velocity, the moment will be greater for the next species. If you are striking with the lower velocity, surely the next one will move with the smaller velocity. But if mass is 0, in this formula m1 v1 equal to m2 v2, if the value of m1 is 0, what will the multiple value of these two? That is the momentum. That must be 0. और अगर इसकी वैल्यू 0 है, what's about the next one? Next क्या होगा? Whether this one is going to change? This one will not change, because if value of m1 is 0, the m1 v1 will also be 0. That is suggesting that the movement of electron is possible. The emission of electron is possible only in the case when the light have the particle nature, light have the massy nature. So this photoelectric effect is suggesting the particle nature of light. So here you can say for any of the light system, you can say that light is not a classical wave. Light is electromagnetic wave which have a unique property other than the classical waves. These are the photoelectric waves are capable to travel even in the vacuum. They have the different energy values that depends upon the which depends upon the frequency as well as the wavelength. So according to this one, energy of a wave for any photon E is proportional to wavelength nu, or you can say that E equal to h nu. For one photon of light. Similarly, E equal to h c by lambda, because nu equal to c by lambda. So these are the energy formulas on the basis of which you can calculate the energy of any of the photons. Now, how the photoelectric effect can be calculated? How the energy of the photoelectric effect can be calculated? If you are saying, I am removing it. If you are saying that any photon having energy E is striking on the surface of the activated metal surface, then what is the minimum energy needed for the removal of electron? the minimum energy which is needed for the removal of electron from the activated metal surface, that is called the threshold energy, which can be represented with E naught, threshold energy. Surely if E equal to E naught, then energy will be removed, or if E is greater than E naught, then the energy will remove. But if the value of E, that is the striking light, will be lesser than the needed amount for the removal of electron, then there will be no removal of electron will take place. But in the case when E is greater than E naught, then what's about the remaining energy? अगर हम ऐसा कुछ एक्सप्लेन करें, दिस इज द चॉक, ओके, एंड आई एम ट्राइंग टू हिट इट जस्ट एनफ दैट इट रीचेज हियर at the end of my hand, then what happens? Just it will reach here and will stand here. But if I am striking with a greater energy, then what happens? With that greater energy, that will continue moving. That means the remaining energy will remain in the form of the kinetic energy. And so in this case, the remaining energy will survive in the form of the kinetic energy, half mv square, and this is the equation for the photoelectric effect. You can also write it in the form of h nu, because you knew well that the E equal to h nu, so you can write h nu equal to h nu naught plus half mv square, where nu naught is threshold frequency. Or you can write it in the form of the wavelength. So it will be h c by lambda equal to h c by lambda naught plus half mv square, where lambda naught is threshold wavelength. So in this way we can calculate the photoelectric effect, or the energy of the electron which is emitted from the system, or minimum energy which is needed for the emission of electron, etc. In the next class we will discuss about the Bohr's atomic model. This time we have just discussed about the nature of light. Next time we will discuss about the Bohr's atomic model and what was the limitation with the Bohr's atomic model. Till then, bye. Have a nice day.